Our sixth lecture video on work, power, and energy is going to cover the topic of kinetic energy. In the last video, we looked at potential energy calculations. Now, what we are going to focus on the other form of energy we will talk about in this class, which is kinetic energy. Kinetic energy is dependent on the mass and velocity of a moving object. To calculate the kinetic energy, we will take 1/2 m times v squared, where Ke stands for kinetic energy, m represents mass, and v represents velocity. The units for kinetic energy are going to be the same as potential energy, which is either foot-pounds or joules, depending on which system the rest of our units are in. Let's take a look at a quick calculation involving kinetic energy. A 75.5 gram projectile is fired with 2,250 joules of kinetic energy. Find the initial velocity of the projectile. We will first write down all of the data from the problem statement. The mass is 75.5 grams. However, we typically want mass in kilograms, so that will be 0.0755 kilograms. The kinetic energy of the projectile is 2,250 joules. We are trying to find the initial velocity v of the projectile. The basic equation we need to calculate a problem involving kinetic energy is that kinetic energy Ke is equal to 1/2 the mass times the velocity squared. In this problem, we want to rearrange the basic equation to solve for the velocity. In order to rearrange the basic equation, we will multiply both sides by 2 divided by m, and then we will take the square root of both sides to get a working equation of v equals the square root of 2 times the kinetic energy divided by the mass. Next, we can substitute in all of the data we are given. V equals the square root of 2 times 2,250 joules divided by 0.0755 kilograms. This should give us a velocity of 244 meters per second. Taking a step back to look at the units quick, 1 joule is 1 kilogram meter squared per second squared, so when we divide that by kilograms, we have meters squared per seconds squared. Taking the square root of that is how we end up with the units of meters per second. This concludes our discussion on kinetic energy.